Hi everyone, welcome to my Casio fx-115ES calculator tutorial. Thank you for watching. If you like this tutorial, make sure to share and subscribe. Feel free to comment below and let me know the type of tutorial that you'd like to learn. Today, I'd like to share with you about determinants, matrix transpose, inverse matrix, adjoint of matrix, and identity matrix using the calculator. For second order determinant, and here you have for A1, A2, B1 and B2, and the result is A1 multiplied B2 minus A2 multiplies B1, and there you go, the 2 times 2 determinants. In order to get to this determinant function in the calculator, follow this step. First, we need to store a matrix into a matrix A. So in this case, you can go to a mode, number 6, the matrix, and then select matrix, which is A. And then let's say we have a 2 by 2, which is a number 5. So we're going to get, let's say 1, 2, 3, 4. And then we're going to store it, press AC. And here you have a matrix that's stored in the A. And then we're going to go to the determinant function, which is go to shift. And then 4 stands for matrix right here. And here we already stored the number on a matrix A, which is just a double check, plus 3. And here this is what we just stored recently. And to find the determinant for the matrix A, shift 4. And here you have a number 7, which is a DET, stand for determinant. So click the 7. And then go back to again shift, matrix, and select the matrix A that you just entered a while ago. And then click equal. And this is the matrix 2 by 2 with the determinant of a minus 2. Let's do an example here. Here, we're going to go to mode and 6 matrix. We're going to store the 2 times 2 matrix in the matrix B. So we have a minus 8, or negative, I'm sorry, 2. So 2 times 2. So you're going to have a negative 2. I'm sorry, negative 8. And then negative 2. 6, 11. Then make sure you press AC to store in matrix B. And then we're going to go to find the determinant for the matrix B. Go to shift 4, and then we're going to number 7, the determinant. Go to shift again 4 matrix, and then we're going to select number 4, which is matrix B. And here you go. You're going to have a minus 76 for this matrix 2 times 2. How about for the third order determinant? You repeat the same step. So go to the mode, and then we're going to 6 matrix. And this time we're going to select 3, matrix C, and we're going to select 1, which is 3 times 3. So we're going to select 1, and we're going to enter the number here. Here we have 1, 2, 3, and then we have 4, 5, 6, and 7, 8, 9. Make sure you save it. And then we go to find the determinant on this 3 by 3 matrix. So we're going to shift, matrix, and then go to number 7, which is a determinant. So we're going to shift again, matrix. And here we know that we store the 3 by 3 in number 5, which is matrix C. So just click 5, and there you go. You have matrix 5 as 0. And let's do another example here. So here we're going to go to mode 6 matrix. You just use A. We're going to choose 3 times 3. So here we're going to store 10, 5, -7. Sometimes the negative and the minus is interchangeable. You can use either one, but it would be a good idea to stick with the negative sign right here. It's kind of like good practices. 7, -2, or -2, and then 3. Oops, just delete. The wrong one. 3, and then -2, 13, and 6. So here you're going to make sure you save it. And then we now go to find the determinant of this 3 by 3 matrix. Go to Shift 4, number 7, determinant of the matrix A. Here we have a minus 1359. So once you understand the determinant concept, that calculator actually help you know to expedite the calculation, and this is pretty helpful when you do the exam, because if not for 3 by 3 matrix, you have to multiply A1 B2 C3, and then for A plus A2 B3 C3, and then plus A3 B1 C2, minus A3 B2 C1, and A2 B1 C3, and minus A1 B3 C2. So it's kind of take a bit longer time to resolve the determinant, especially if you have a fraction, and that will even make things harder. But with a calculator, it's kind of like speed up the thing. Next, let me show you on the matrix transpose. Here, the row will become the column, and the column will become the row. As you can see here, A, the B, C, D, which is on the first row, will become a column 1, B, C, D. And then on the row number 2, E, F, G, will become a column 2, E, F, G in the A transpose. So in order to get to this A transpose function, and we first need to store a matrix first. So go to the mode, and then 6, and then matrix A. So let's say we're going to do 2 by 2 matrix in this case, right? So we're going to select number 5, and then same thing, 1, 2, 3, 4. And here we have 1, 2 on the row number 1, and a 3, 4 on the row number 2. So we save it, go to Shift 4 matrix. So the Shift 4, right, and you see on the top, always refer to the matrix function here. And here we restore the matrix into the matrix A. And then it'll get to the transpose, and you can see on the number 8 right here, TRN, that stands for transpose. So just click A, and then we're going to Shift again, and then 4 matrix. And here we're going to select number 3 that we just entered a while ago. So just enter 3, and then equal sign. As you can see that the 1, 2 that was supposed to be previously on the row 1 become column 1. As for the 3, 4 on the row number 2, it become the column 2 in this case. Let's do a couple examples here. Let's say if you have a matrix of A, and which is 2 times 3. So in this case, we're going to the mode, and then number 6 matrix, and then we're going to store the matrix A here, and then this is going to be 2 times 3 matrix, 2 row and 3 column, and you're going to select number 4, and here we're going to key the number 1, 2, 3, 4, 5, 6. Save it, and then we go to Shift matrix, select number 8, transpose, and then Shift 4 matrix. Since we put on the matrix A, number 3, click that, and here you can see that it become matrix of 3 row and 2 column, and 1, 2, 3 is on the column 1, and the 4, 5, 6 is on the column 2. Another example is 3 times 3 matrix. So here we go to store the matrix 6, then we store the matrix number B, And this is going to be 3 times 3, so we select number 1. And here we're going to enter a number -5, 9, 10, 7, -3, 2, 12, 11, -20. Okay, make sure we save it. Then we're going to a shift matrix, and then we're going to number 8, transpose. Go to shift 4 matrix, and then we're going to transpose matrix A in this case, which is 4, and that will give you the 3 times 3, but with -5, 9, 10 that's originally on the row 1 become the column 1 right here, and the same for the rest. Next, on the calculator, let me show you on the inverse matrix. Same practice. First, we need to store the matrix into the calculator first. So go to mode 6 for matrix, and then we're going to store a 2 by 2 matrix in the calculator. And then 1, 2, 3, 4. Save it, and then go to the shift 4 for matrix. And here we know that we store on the matrix A, so select number 3. And this is a tricky part right here. Let's say in order to do inverse, if we use this one, powers -1, this one, you're going to get an error. So in order to do an inverse matrix, we have to use this function right here, button, which is x-1 right here, power -1. So go to shift 4, and then matrix A, number 3. Select the x power -1 button right here. And here you will see that matrix power -1. And this is inverse matrix A. Enter. And this is number -2, 1, 1.5, and -0.5. And this is the inverse of the matrix A. Let's do another example here. So the next case is that we're going to store a matrix and a matrix B, and we're going to do the 3 times 3 matrix. So here we're going to have -5, 9, 10, 7, -3, 2, 12, 11, and -20. So this is that we entered previously. It's still stored on the matrix B at the here. So everything is still correct. Just save it. Go to shift and then 4. And then we're going to select matrix B. Be sure that you go with x power -1 button right here. So this is inverse matrix B. Enter equal. And here you go. It gives you the matrix for the B. And as you can see, it gets more complicated because you have some decimal number. But with using the calculator, it can make things a little bit much more easier. Next, let me show you on the adjoint matrix. So by definition, right, adjoint of matrix A is equal to adjoint of matrix A, which is obtained by replacing the transpose of matrix A with their cofactor. And this is given by the equation right here, which is inverse of matrix is equal to adjoint of matrix A divided by determinant of a matrix A. So how can we use a calculator to calculate the adjoint of a matrix A? In order to do that, first we need to store the matrix in the matrix A calculator. In order to clear the matrix that we just stored previously, basically just click Mod, press 1 computational, and all the matrix will be clear that you stored previously. So now we're going to store a 2 by 2 matrix. Go to Mod, 6, and then here we're going to select matrix A, and then 2 by 2. So as you can see here, it's clear already. So we have to enter 1, 2, 3, 4 and save it. Then we're going to go to the shift and the matrix. And here we have to understand the definition. In order to get the adjoint A right, you have to multiply the determinant of the matrix A by the inverse of matrix A. And on the previous tutorial, we already talked about how to get the determinant of the matrix and also the inverse matrix. So this makes it a little bit easier to find the adjoint of the matrix A. So in order to do that, we're going to multiply first matrix A, which is the inverse matrix A, and this one, power minus 1, and it's going to be multiplied by the determinant. So shift for matrix, and then you're going to select number 7, which is a determinant, and then going to be go back to shift and matrix, and then we're going to select 3, which is a matrix A, and click equal. And here we go. This is the adjoint of the matrix A. By multiplying the inverse of a matrix A with the determinant of the matrix A. Let's do another example here, which is a 3 by 3 matrix. So to find the adjoint for the matrix B with a 3 by 3 matrix, so we go to mode, go to number 6, and then we're going to, this time we're going to store on the matrix B 2, and we're going to select number 1, which is a 3 by 3 in this case. So we're going to enter minus 5, or negative 5, 9, 10, 7, minus 3, 2, 12, 11, negative 20. So make sure we save it. Okay, and then we go to shift and matrix. And here just as a reminder that the adjoint for the matrix B is equal to the inverse of a matrix B multiply the determinant of a matrix B. So we're going to have a matrix B, which is inverse, this button s power minus 1, multiply the determinant of the matrix B is number 7. Then we have to go back one more time, shift matrix, and here we're going to have a number 4, determinant of matrix B here. So we can just look at our equation one more time. So it's a matrix, inverse of matrix B, multiply the determinant of the matrix B, and then click equal. And here we go. This is a adjoint for the matrix B. The next topic is about the identity matrix using the calculator. By definition, in order to get the identity matrix, the matrix A is multiplied with the inverse of the matrix A, or inverse of the matrix A multiply the matrix A, and that will give you the identity matrix. So for 2 by 2 identity matrix, the 1 and 1 will be at a diagonal, and the 3 times 3 matrix, same thing, the 1 will be on the diagonal as shown here. So let's find the identity matrix in this case. First, let's clear the matrix that we just stored previously, and then we're going to do a 2 by 2 and followed by 3 by 3. In order to do that, go to the mode, then select matrix, and then matrix A, and here we're going to select the 2 times 2, which is enter a number 1, 2, 3, 4, and make sure to save it. And then let's go to the same or the function of the matrix. You go to shift and matrix. So just to remind again, the matrix A multiply the inverse of a matrix A is equal to the identity matrix. So we're going to start with a matrix A, multiply the inverse of the matrix here, so which is one more time, number 3, and then make sure you select power minus 1, this button right here, and then just equal. As you can see that the 1 and 1 is on the diagonal right here. And let's try the second one, which is 3 times 3 matrix. So same thing, go to mode, and then 6 matrix. Number 2, we're going to select 1 as a 3 times 3 matrix. We're going to enter a number here, -5, 9, 10, 7, -3, 2, 12, 11, -20. Make sure we save it. So we have a save it matrix B right now. So we go to Shift 4, and just to double check the matrix B, and this is the we just entered a while ago. Okay, go to Shift Matrix. So the identity matrix for 3 times 3 matrix is actually the matrix B multiply the inverse of the matrix B. So select number 4 matrix B, multiply Shift Matrix, and go to select the matrix B one more time, and then going to be inverse, which is this power minus 1, and then click equal. Here we go, you see a diagonal on the center right here. And just wanted to prove another definition. It's actually the matrix for the identity is equal the inverse matrix here, multiply the matrix here. So we just do this, repeat the same, Shift 4. Going to be the inverse of a matrix B, multiply 4. So that will give you the identity of the matrix B. Here you go, it's the same number here. Thank you for watching. Don't forget to check out my other video on matrices, storing the matrix, addition and multiplication. I have posted the quick tips at the description. Feel free to comment and share. Remember to check out my other calculator tutorial. Have fun learning and applying.